Concrete can hold massive amounts of downward pressure, but it easily cracks under tension. To prevent this, concrete needs an internal skeleton. This document outlines what that skeleton looks like. It is called a reinforcement cage. It is a three-dimensional steel frame made by joining heavy bars and wire links together. Placed inside columns and beams, it prevents cracks and allows the structure to support heavy loads. Our objective is to build a perfectly tied, rigid steel frame from scratch, ensuring it is entirely complete and stable before it is dropped into the wooden formwork. Before you handle any materials, you must prep your workstation. You will need thick safety gloves, dedicated cutting and bending tools, and a clean, organized workspace. But those tools are useless without a plan. Before a single piece of steel is moved, you have to consult the reinforcement drawings. These blueprints are the absolute source of truth for your measurements. Step 1 is organization. Start by gathering your raw steel bars and laying them out clearly across your workstation so you can measure them properly. Consult your reinforcement drawing to find your target lengths. You need to extract the exact quantities and measurements for the thick vertical main bars as well as the thinner horizontal loops, known as stirrups. Use a measuring tape to mark those required lengths directly on the steel. Then take your cutting tools and shear the bars precisely to the blueprint's numbers. Once the steel is cut, the sheared edges are extremely sharp. You must handle the bars carefully and keep your heavy-duty gloves on to protect your hands. Accuracy here dictates the success of the entire project. If you are off by a few millimeters on your cuts, those errors will compound, and the finished cage simply will not fit into the tight wooden formwork later. Straight rods cannot grip the concrete securely on their own. Once cut, the steel must be manipulated into complex shapes to lock everything in place. We start by creating hooks on the main bars. This involves bending the terminal ends of the steel into curves or right angles. This shaping prevents the thick bars from slipping once the wet concrete cures around them. Next, we shape the stirrups. As the guide shows here, stirrups are the continuous loops of steel that wrap around the outside of the main vertical bars to hold them together. Take the thinner wire you cut earlier and bend it repeatedly. Your goal is to form uniform, identical squares or rectangles, matching the specific architectural needs of your column. Different structural features require specific shapes. For example, a lintel reinforcement requires a dedicated cage shape because it has to carry the weight of a solid wall over the empty void of a window or door. Taking the time to precisely bend these individual hooks and stirrups ensures the final, three-dimensional structure will actually carry the loads it was designed for. Now we will begin the assembly phase. Lay the heavy main bars horizontally across your workspace to create a flat, stable base. Take the square stirrups you just shaped and thread them over the horizontal main bars, sliding them on like beads on a string. Measure the specific gap between each stirrup. You have to manually adjust them along the main bars until the gaps exactly match the drawing. This chart highlights exactly why you cannot rush this step. If you use the wrong size bars or space the stirrups incorrectly, you create weak points that compromise the entire structure. Once the spacing is perfectly aligned, it is time to tie the cage. You will use binding wire to lock every single intersection where a main horizontal bar touches a stirrup. Wrap binding wire around the joint. Grab the ends with pliers and twist tightment to create a firm knot. The guide warns against loose tying. If there is slack in your twists, the intersections will slide out of alignment. To verify your work, grab one of the tied joints and try to physically twist it. If the intersection stays completely rigid, you have built a skeleton that will hold its shape when thousands of pounds of wet concrete are poured over it. With the cage fully tied, step back for a final quality control check. Walk around the freestanding structure, verifying that the main bars are perfectly straight and the overall dimensions match the blueprint. This cage is now a heavy, rigid object. Coordinate with your team to carefully lift the frame together, ensuring the steel doesn't bend under its own weight. Gently guide the completed cage directly over your workspace and lower it down smoothly into the waiting wooden formwork. When the cage drops perfectly into place without snagging the wood or needing to be forced, it proves your measurements, shaping, and tying were perfectly executed. By following these precise steps, you have transformed a pile of loose rods into a highly structured, load-bearing skeleton. To help recall these specific requirements on a busy site, this document offers a simple memory trick, the acronym CSHLBD. This stands for verifying column bars, spacing stirrups, bending hooks, preparing lintel reinforcements, tying belt beams, and checking drawings. With the steel safely fixed, rigorously inspected, and resting securely in the formwork, the site is now completely prepped to withstand the massive force of the incoming concrete.